So, Harini, you are from which town, which board, which uh, standard?
I'm 11th standard, sir.
Okay, okay,
From Government Higher Secondary School, Sundakamuthur, sir.
okay. Near Coimbatore, right?
Yes, sir.
Okay, fine. Okay. So the reason I asked is, this is for 11th standard, so I just wanted to make sure. Today I'm going to cover the first chapter, in 11th standard, which is sets, right? So I'm going to talk about, do some problems
Okay,
on
sir.
sets, okay? So, fine. Let me share my screen now. Okay. Okay. So sets has been completed for you, Ilya. The classல முடிச்சிருப்பாங்க.
Yes, sir.
Okay. So these are some basic points about sets. Okay. Set is a well-defined collection of objects. Okay. A set, if it doesn't have any element, it is called empty set. Okay. If it has definite number of element, it's called finite set. Otherwise, it's called infinite set. Sets can be infinite also because you can define it in such a way that there are infinite terms. So, for example, if you take a set of all natural numbers, that is an infinite set. And then two sets are equal if they have exactly the same elements. So then one set is said to be a subset of, set A is said to be a subset of B if every element of A is also an element of B. Okay. So intervals are subset of R. Intervals in R, real number. If you define an interval, that is a subset of R. Okay. So then there is also a proper subset and regular subset. Proper subset means a subset that excludes the set itself. Okay. Otherwise, subset will include the set also. Okay. Then a collection of all subsets of a set is called a power set. Okay. So if a set contains n elements, if a set contains n elements, then the number of subsets can be it will be equal to 2 to the power of n. Okay. If a set contains n elements, the number of subsets is given by 2 to the power of n. So it is a total number of subsets. That's called the number in the power set. Power set is a collection of all the subsets. Okay. So this is also equal to nc0 plus nc1 plus nc2 plus so on up to ncn, where nc0 is number of subsets with 0 elements. Okay, nc1 is a number of subsets with 1 element, a number of subsets with 2 elements, and so on. Okay. Then that there's a union of two subsets. It means the element can be in either A or B. Okay. So that is called a union. Intersection means it needs to be in both A and B. Yeah, that is the intersection of two sets. Then a complement means the difference of two sets. Okay. So if you say A minus B, that means it should be in A but not in B. So that we refer to as A minus B, the difference of two sets. Then complement means what is not there in A. Okay. So universal set minus the set A. Okay. So that will be your complement. Okay. So for any two sets, this is called De Morgan's law. The next point, the A union B is equal to A union B whole complement. Complement is denoted by this symbol, the apostrophe. Okay. Or you can put a C also, A union B, close brackets, and you can put a C also, or apostrophe. Either one is okay. Okay. Or you call it as A union B whole prime. So when you put an apostrophe, you say that is prime. Okay. It's equal to A prime intersection B prime. Okay. Similarly, A intersection B whole prime is equal to, or whole complement equal to, A complement union B complement. Okay. So that's called De Morgan's laws. Okay. So then this is an important formula. So if there are two sets A and B, and the A intersection B is null, that means there is nothing in common between them. And n of A union B is n of A plus n of B. N of A means number of elements in A. Okay, so the number of elements in the union will be number of elements in A and plus number of elements in B. But if that intersection is not null, because there are some common elements, then that common element is counted 2 times when you add NA plus NB. Therefore, we subtract that once you subtract that, so that you don't double count. Okay. So that means n of A union B is equal to n of A plus n of B minus n of A intersection B. Okay. So ordered pair is a pair of elements grouped together in a particular order. Here order is important. Okay. A comma B is not the same as B comma A. Okay. Then if there are two sets, their Cartesian product is given by ordered pairs of every element in A followed by every element in B. Okay, so how many ever combinations like that you can make. So that actually you can make n of A into n of B such combinations. So that's called Cartesian product. Then okay, in an ordered pair, A comma B, if you say A comma B equal to X comma Y, then it is true that A must be equal to X and B must be equal to Y. Okay. So then if n of A is P and n of B is Q, then n of A cross B, or Cartesian product of A and B, so that will be given by PQ. So because for every element of A, there is a, you can pair up with one element of B. So there are n elements in A and P elements in A and Q elements in B. So you can pair up in PQ number of ways. Okay. So A cross or A, there are two sets. One is A and other is a null set. A cross null set is a null set. Okay. In general, the Cartesian product A into B is not equal to B cross A, because the order is important. We already saw that. Okay. So when we do some problem, these concepts will become more clear. But for now, I want to stop and ask you whether you have any questions on any of these. Do you understand all these concepts, Harini?
Sir, please once more explain what is power set, sir.
The power set is a collection of all subsets. Let me write it down. Okay. Suppose set A equal to 1, 2, 3. So what are all the subsets? Okay. Null set is one subset. Okay. This is one subset. This is one subset. Correct? This is subset because we are taking something from the whole. We're not taking everything, but whatever. Anything in this set. This is subset. Okay. It should be there in A set. That is the only condition. Okay. Since 1 is there, right? So 2 is there, and so on. Similarly, then 1, 2, if you make a set like this is also a subset, right? 1, 3, this is also a subset. 2, 3 is also a subset. Okay, so these are all subsets of A. Do you understand, Harini? Do you agree?
Yes, sir. Thank you, sir.
Okay. Now, if you create a master set, of all these, a set of all the subsets, okay, so that is called a power set. Power set is a set of all the subsets of a set. Okay. So here, this set has got 3 elements. Okay. Therefore, this power set, okay, this is the power set. P of A, we can say. I'll write it clearly. N of PA, power set, is equal to 2 power N of A, 3. You can see that, how that 8 comes. 1, 2, 3, 4, 5, 6, 7, 8. Because the number of elements in the power set is 2 to the power of number of elements in the set itself. Okay. So this is also equal to how many sets you can make with 0 elements. NC0, that is 3. 3C0. There are totally 3 elements. So how many combinations you can make with 0 elements? How many you can make with 1? How many we can make with 2? How many we can make with 3? Okay. So if you look at it, so how many you can make with 0 is only the null set, right? That is only 1. How many we can make it 1? Those are 1, 2, and 3. Okay. How many you can make with taking 2 elements at a time? 1, 2, 1, 3, 2, 3. 3 with all the 3 elements, that is 1. Okay, 1 plus 3 plus 3 plus 1. So that is 8. Okay. So that is also equal to 2 cube. Okay. So NC0 plus NC1 plus NC2 plus NC3, okay, is also equal to 2 to the power of n. And that is the number of elements in the power sets, or the total number of subsets of a set. Is that clear, ma?
Yes, sir.
Okay. Now that we have seen these concepts, okay, good, Sridhar. Now, if we start doing some problems, so then it will become more clear. See, I want to make it very clear that the objective of these classes are to interact and ask any questions and clarify your doubts. Okay. Otherwise, there are n number of videos available in the internet. Okay. So you type any topic, any problem, you'll get some video for that. But you will still have doubt. Okay. So that is why that is the difference. In a face-to-face class or this type of a class versus a recorded video. Okay. So I encourage you to ask your doubts and clarify. I am here only to clarify your doubts. Make sure you understand. That's why I try to prompt you whether you do understand, and I ask you to do the sums yourself. Okay. Okay. So let's go ahead. Some problems. Okay. There is a statement, a problem like this: a set of weak students in a class. So what type of set is this? Is it a null set? Is it a singleton set, a finite set, or a not a well-defined collection?
Option D, sir.
Yes. Because a weak student, to me, one who looks like a weak student may look like a better student, a good student for somebody else. So it's not very clearly defined, a weak student. Whereas if you say in the last test, the set of students who got, 40 marks or below. Okay, so if you say that they are or less than 40, if your 40 is your cutoff, so the set of students who got less than 40 marks, if you define like that, it will be a finite set, because the number of students, it's a finite number will be there. Okay, that is clearly defined. But if instead of that, if you simply say weak students, so we don't know what is a weak student, right? So the answer is D, not a well-defined collection. Okay. Okay, let's look at the next problem. Which of the following is an empty set? Okay. X is a real number and x square minus 1 equal to 0. X is a real number and x square plus 1 equal to 0. Okay. The set of, all the numbers x, so that x is a real number and, all the other conditions, which is a empty set. What this means is that x, and then if you say two conditions, like here x is a real number and x square minus 1 equal to 0, it is a set of all values of x which satisfies both these conditions. Both these conditions. And it should be a real number and it should be x square minus 1 equal to 0. It's a real number and it should satisfy x square plus 1 equal to 0. So, which is an empty set out of these? Okay. So if you take x square minus 1 equal to 0, that means x equal to plus or minus 1, right? And it is real number. So that set will have two numbers, minus 1 and plus 1. So it is not an empty set. So it's a finite set with two elements, right? So like that. So what about the second one? X is a real number and x square plus 1 equal to 0. Is it possible? When you say x square plus 1 equal to 0, x square equal to minus 1. That means any square cannot be negative, right? Square will always be positive. So here we get x square equal to minus 1. So there cannot be a real number that satisfies this condition. So there is no real number that satisfies x square plus 1 equal to 0. That means B is a null set. Okay. C, again, x is a real number, x square minus 9 equal to 0. So there are two solutions here, because x square equal to 9, x equal to plus or minus 3. So this set will have plus 3 and minus 3. So not a null set. Out of the fourth one, x is a real number and x square equal to x plus 2. So x square equal to x plus 2, you can try to solve it, okay, using quadratic equation formula. X square minus x plus 2 minus 2, right? Let's write down. X square equal to x plus 2. It means this is problem number 2, right? X square minus x minus 2 equal to 0. In x equal to, you can use that quadratic formula. Minus b plus or minus root of b square minus 4ac. 8, right? 8. 4 into a into 4 into a is 1, c is 2. So 4, c is minus 2. So 4 into 1 into minus 2 is minus 8. Minus of minus 8, so 1 plus 8 will divided by 2. 2a. So that is 2 here. So this is 1 plus 8, 9. Square root of 9 is 3. So there is a solution. 1 plus 3 by 2, which is 4 by 2. 1 minus 3 by 2 is minus 2 by 2, which is minus 1. So there are two solutions. This set is going to have two values, 2 and minus 1. Okay. So then this is not a null set. Okay. So that means B is the correct answer here, because that is the only one where there is no solution, and therefore that will be an empty set. Okay. Let's look at this problem. Set A equal to x. X belongs to real number. X square equal to 16 and 2x equal to 10. Okay, so all these conditions should be satisfied. So what are the values of x that will satisfy all these conditions? So x is to be real. X square equal to 16. With what values of x will satisfy this x square equal to 16?
4, sir.
plus or minus 4. Okay, plus 4 square is 16, minus 4 square is also 16. So plus or minus 4. 2x equal to 10.
5, sir.
X equal to
Plus
5.
5.
Plus 5. So, is there any value of x that satisfy all the three conditions? X is real, x square is 16, 2x equal to 10. Nothing, right? So plus 4 and minus 4 satisfy only this condition, but is not satisfying the third condition, 2x equal to 10. Okay. So x equal to 5 will satisfy this one, but it will not satisfy x square equal to 16. Therefore, there is nothing that satisfies all the three conditions. That means that is a null set. Okay. Okay. So let's look at the problem number 4. If a set A has n elements, the total number of subsets. We just now saw that. I explained that. So what is the answer to this?
2 power n, sir.
It is 2 power n. Okay. It is 2 power n. Very good. Okay. The number of proper subsets of the set 1, 2, 3 is. Okay. The set has got 3 elements, 1, 2, and 3. So the number of proper subsets, how many are there?
8, sir.
8 is a total number. So how did you get 8, Harini? Can you tell me?
Sir, number of proper set formula is 2 power n, sir.
2 power n is not proper. Okay. It is number of subsets. Okay. The number of subsets is equal to 2 power 3. Because here the number of elements is 3. Therefore, the number of subsets is equal to 2 power 3, which is 8. So what is the difference between a subset and a proper subset? The proper subset excludes the set itself. Okay. The set itself we have to remove. That is the one with all the values 1, 2, 3. That is a subset, but not proper subset. Okay. Proper subset, you have to exclude the set itself. So then how many number of proper subsets are there? It's 7, because out of 8 you have to remove the one set. Okay. So remove 1. So you get 8 minus 1. That is 7. Okay. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now let us do some calculations. So given that A equal to 1, 2, 3, B equal to 3, 4, and C equal to 4, 5, 6, then can you calculate A union B intersection C? Please, do you know how to do this? Calculate the intersection and union. We saw the definitions, but this is, just to apply that.
Sir, option D, sir.
Option D. D is it? 1 minute. C equal to 4, 5, 6. I'm writing it down in the board.
Sir, option B.
Okay, you're getting different answers. So let me check now. A union B intersection C. A union B intersection C. A union B intersection C. Now I come to the board. Okay, can you all see the problem? I have written it down. So A equal to 1, 2, 3, B equal to set having 3, 4, C equal to 4, 5, 6. So A union B intersection C. Okay, so first calculate, let us calculate B intersection C. What is B intersection C?
4, sir.
Yeah, only 4. Right. Now A is 1, 2, 3. So A union B intersection C is what then?
1, 2, 3, 4, sir.
Very good. So that will be, which option is that?
B, sir.
Option B. Okay. Okay. So let's look at this. A and B are any two sets. Then A union A intersection B is equal to what?
A, sir.
A. Okay. Who said A? Harini.
Harini, sir.
Okay. What about Prasanna Devi? Could you agree? Okay. So
Yes,
let's draw.
sir.
Okay. So let us draw a Venn diagram. Venn diagram, the diagram of two sets like that. Okay. So this is your A, and this is your A intersection B. So A union A intersection B. So set of elements that can be in either this or this is again A only, right? So you can see from the diagram that it is A. Okay. So option A. Okay. Option A. Okay. A and B are two given sets. A intersection B complement. What is this? A bit confusing. A intersection A intersection B whole complement. What is that? So again, let's draw a Venn diagram. So for that, we have to draw a universe. Okay. So let us say this is your universe. Okay. So within that, you draw A, and then you draw B. This is your A and B. Now let us draw this. A intersection B is this. So that means A intersection B whole complement means everything outside of A intersection B. This whole thing is A intersection B complement, means it should not be in the A intersection B. Otherwise, everything is acceptable. Everything is in this A intersection B whole complement. So all this that I have drawn, using this line, this cross line. Okay. So they're all A intersection B whole complement. Now A intersection. So how much of this whole thing is also present in A? That means it should be within this also, and it should also be in the A intersection B complement. That means it will be like this. ஒரு பிறைச்சந்திரன் மாதிரி இருக்கு. பிறைச்சந்திரன் இல்லை, அது பௌர்ணமி கிட்ட இருக்கிற சந்திரன் மாதிரி. ஹோல் சர்க்கிள்ல ஒரு பிறைச்சந்திரனை எக்ஸ்க்ளூட் பண்ணிட்ட மாதிரி. Okay, so this is that area. Okay, so what can we write about this? This is, you can see that this is A minus A intersection B. Okay? So that is what you see, right? A minus A intersection B. But what are the options given? So it is not A, it is not B, it is not null. Okay. So it has to be the other option, A intersection B complement. So see, what is A intersection B complement? So A intersection B complement, if you take, again, if you draw a diagram, so B complement is all outside B. All outside B. It should not be within this B. And A intersection, right? A intersection B complement. A intersection. So how much is common with A? So you see that again it is this one, the same thing which is coming. So that means this is the correct answer. Okay. So you can also use De Morgan's law in this case. Okay. Let us use De Morgan's law. So what is De Morgan's law? A intersection B whole complement is equal to, what is A intersection B whole complement? We saw that, right? A complement union B complement. That is the De Morgan's law. A intersection B whole complement is equal to A complement union B complement. You can draw a diagram and verify. Okay. Now, A intersection A complement union B complement is equal to A intersection A complement, okay, union A intersection B complement. This is again property of sets. Okay, when you want to there is one A union A complement union B complement, which you want to take, intersection with A. Okay, so you can split it in two terms like this. Okay, so this A and A you take, okay, and this B A intersection B complement you take, and you take the union of these two. Okay, so and what is A intersection A complement? It should be in A and it should not be in A both. That means this is null. Okay, union. So anything union null is that itself. So it is A intersection B complement. So using De Morgan law also, we are getting this answer, A intersection B complement, right? That was the answer, right? A intersection B complement. Right. I hope it's right. No, raise it. I'm asking you, is it clear? Problem 8?
Yes, sir.
Okay. Okay. So let's move on now. So we are in problem number 9. Please look at problem number 9. Okay. Look at problem number 9. If A equal to x comma y, x square plus y square equal to 26, and B equal to x comma y, x square plus 9y square equal to 226, then A intersection B contains how many points? Very interesting point, problem. Okay. Let me write it down. Okay, I copied the problem to here. I hope it is readable, right? Okay. Now, what we have to do is, so what are the values of x comma y that will satisfy both these conditions? We saw in an earlier problem also, right? So here, if it is given that, yeah,
Sir, when x is equal to 1 and y equal to 5.
okay, then this is satisfied, right? Okay, x square plus y square equal to 26. This is one condition, okay? The other condition is x square plus 9y square equal to 226. Okay. Now, both these conditions should be satisfied, right? So, just try to see what are the values. You rightly said, okay? X square plus y square equal to 26. That is satisfied when x equal to 1 and y equal to 5. And likewise, it is satisfied when x equal to minus 1 and y equal to 5, x equal to 1 and y equal to minus 5. So many combinations are there. Okay. So, and what about the other one? And it is not telling that these need to be integers. No, that can be non-integers also. Okay. It can be non-integers also. So any value of x you can take, not necessarily integers. So you can take x equal to 2 also. Okay, if you take x equal to 2, what happens? X square is 4, so y square will become 22. So you can take square root of 22. So that is also correct, because it doesn't say x and y are integers. Okay. Now it's simple. What you should do, what is the intersection of these two? Let us, you can try to draw it. X square plus y square. You have studied, I hope you have studied circles, or this is the equation of first condition. X square plus y square equal to 26 is a circle with center equal to 0. Okay. So this one is x square plus 3y the whole square equal to 226. Let us try to solve this. Okay. Okay, so this will be like a parabola. I'll write. Okay. So actually, these are the two equations, right? So you simply subtract 2 minus 1. Okay, it's like a simultaneous equation of these two conditions. So subtract 2 minus 1. Okay, what it will give? 8y square equal to 8y square equal to 200 y square equal to 25, y equal to plus or minus 5. So only y equal to plus or minus 5 is going to satisfy both these conditions. Okay. So now if you put y equal to plus or minus y, what is the value of x? You can determine. Okay. So x will be plus or minus 1. Okay. We substitute x square plus y square. X square plus y square equal to 26, right? Means x square plus 25 equal to 1. Means so x square plus y 25 equal to 26, or x square equal to 1. So x equal to plus or minus 1. So y equal to plus or minus 5, x equal to plus or minus 1. Now substitute in the other equation, x square plus 9y square equal to 226. And since y square is 25, 9y square is 225. So this also gives us the same thing, x square equal to 1 or x equal to plus or minus 1. So the solutions are 1, 5, 1, minus 5. You see, plus or minus 5. It is very important. Just not, plus 1 and plus 5. So you take all these combinations like this, 1, 5, 1, minus 5. Then minus 1, 5, minus 1, minus 5. So these are the 4 points at which these two curves will intersect. Actually, both of these are curves. Okay, so and they will intersect at 4 points. Okay, these are the 4 points. So the answer is 4. A intersection 3 B. That means both these conditions should be satisfied for 4 points. Okay, if the second condition is not there, if only one, the first one only you take, there are infinite points, right? For any value of x, you said one solution, there's 1 and 5, but like I said, there can be infinite solutions. But if both these conditions need to be satisfied, then there will be only 4 solutions. Okay, so the answer is 4. Did you follow?
Yes, sir.
Okay, good. Now look at Harini. Are you okay? Any doubt?
Yes, sir. No,
Okay.
sir.
Okay, now let's look at problem number 10. In a class of 30 students, every student reads 5 newspapers and every newspaper is read by 6 students. So then how many newspapers are there? Okay. So there are number of students is 30. Since every student reads 5 newspaper, then the number of ordered pairs, okay, number of ordered pairs So if you make a ordered pair like a student and newspaper, then how many such pairs will be there? Since every student, there are 30 students. On every student, there are 5 newspapers. And therefore, it should be 150. Okay. So the number of ordered pairs of students and newspapers comes to 150. Now, you reverse this order. Okay. Then you get number of ordered pairs of newspaper and student is also 150. The number of ordered pairs of newspaper, comma student. Okay, so that is also, these two are not equal because the order is different, but the number is same. Okay, that is. So now, every newspaper is read by 6 students. Okay, so now again, suppose the number of newspapers is n. Okay, so now this ordered pair will be given by n into 6. Okay, because read by 6 students. N into 6 equal to 150. The number of newspapers, if it is n, then for each newspaper is read by 6 students. Therefore, the number of ordered pairs of newspaper, comma students will be n into 6. But we know that it is equal to 150. So n into 6 equal to 150. So n equal to 150 divided by 6 is 25. So there are 25 newspapers. There are 25 newspapers. So this is actually 30 into 5. Okay. Is it clear? Any doubt?
No, sir.
Okay. Good. Let's look at this problem. Problem number 11 now. Problem number 11. Okay. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach physics and mathematics. So how many teach physics only? In a school, there are 20 teachers. I'm going to write it down on the board. See, let us say the number of teachers who teach mathematics equal to m. Okay, that set of teachers. Okay, let us say the set of teachers who teach mathematics equal to m. The set of teachers who teach physics to p. Okay. Now it is given that there are 20 teachers who teach mathematics or physics. So how can we write it in set notation? Number of people in the set who teach mathematics or physics. That means m union or intersection. If it is Mathematics and physics, you will put intersection. It is mathematics or physics, either one. So M union P. N of M union P is given as 20. 12 teach mathematics. N of M equal to 12. 4 teach physics and mathematics. Physics and mathematics means M intersection P. Okay. So this is what is given. How many teach physics only? Okay. See, here is mathematics, here is physics. Physics only means this is what we want. How many teach physics means, okay, you can take the whole circle for P. When you say physics only, we take this much only. That means N of P minus N of M intersection P. This is useful because they are teaching maths also. So when you want to count only like this, physics only, then you have to take NP minus N of M and P. This is what is wanted. Right. Now, M union P, write a formula for M union P. So from that, let us see if we can get this. So what is the formula for M union P?
N of M plus N of P minus N of M intersection P.
Very good, very good. So here we have this, we have this, we have this. So we can get N of P now, right? We can get N of P because this is 20, this is 12, this we don't have. M intersection, this is 4. Right? So 20 equal to 12 plus N of P minus 4. N of P, 12 minus 4 is plus 8. So N of P plus 8 equal to 20. So what is N of P? N of P is 12. N of P is, from this formula, we can calculate N of P as 12. And what do we need? N of P minus N of M intersection P. So number teaching physics only. So we have N of P is 12. M intersection P is also we know 4. Therefore, the answer is 8. Okay? Number of teachers who teach physics only is equal to 8. Equal to 8. Okay. I hope you followed, right? Otherwise, please look at it for some time. Make sure you understand this. Okay. Then we can move on. Is this clear?
Yes, sir.
Sir.
Okay. Let's move on. Next problem. We are on problem number 12 now. Okay. Let A and B be two sets containing 3 and 2 elements respectively. Then the number of subsets of the set A cross B. Okay. Cartesian product. We saw Cartesian product, right? A cross B. Each having at least 3 elements. Okay. How many are there? Okay. Each having at least 3 elements. Right. Okay, so I have copied the problem here, the board. Okay. So given that n of A equal to 3, n of B, there are two sets A and B. Then number of elements of set A is 3, number of elements of set B is 2. The number of subsets of the set A cross B. Okay, so how many elements will be there in A cross B?
6, sir.
6. Because this is for every combination we have to take, right? Here there are 3 and here there are 2, so combinations is n of A cross B is n of A into n of B, which is 6. Now, there is this n of A cross B, which is a set of ordered pairs. It has got 6 elements. Okay. Now that is having 6 elements. Now there is a set having 6 elements. How many subsets are there for this set? Okay. There is a set having 6 elements. Then how many subsets are there for this set? We already saw that, right? 2 to the power of 6. So those many are the total number of subsets, right? But I also said it is equal to NC0 plus NC1 plus NC2 plus NC3 plus NC4. The 2 to the power of n is also equal to NC0 plus NC1 plus NC2 plus NC. Because in this case it is 6, n equal to 6. Right. Now, what are they asking? They're not simply asking the number of subsets, but they're asking the number of subsets, each having at least 3 elements. Okay. So here is n equal to 6. Let us put n equal to 6. Okay. So I think combinations now, I think you're not taught, right? Probably that maybe it will come to you later in your 11th portion. It is coming, these combinations. This means how many, combinations of 1 you can take out of, 6, how many combinations of 2 you can take out of 6 and so on. Okay. So this you will study later. Okay. But now I want to just explain the how to determine this particular problem. So now since it said each having at least 3 elements, okay, then this is the number of subset having 0 element, 1 element, 2 element and so on. At least 3 means you have to add up these things. 3, 4, 5 or 6. So these many subsets are having 3 elements, these many 4 elements, these many 5 elements, these many 6 elements. So 6C3 plus 6C4 plus 6C5 plus 6C6. Okay. So that is what you have to take. The required number is the sum of these 4. 63 is 6 into 5 into 4 divided by 6. 3 factorial. So that means 20. 64 is same as 62 equal to 6 into 5 by 2. 65 okay. So there are 20 that you can 20 subsets with 3 elements, 15 subsets with 4 elements, 6 subsets with 5 elements and 1 subset with 6 elements. So what is the sum of all this? 20 plus 35 plus 6 plus 1. Okay. So this will be 35, 41, 42. Okay. So if you take 2 power 6, it will be 64. That will include everything, even with the elements 0, 1 and 2. But we want to exclude that. So therefore, it is 6. Either you can calculate like I did, or you can calculate 64 minus 60 minus 61 minus 62. Depending on whatever is convenient. But here the answer is 42. Answer is 42. Okay.
Okay, sir.
Okay. Fine. So I think I will do one. How many problems are I? A number of problems, but we don't. I want to finish set today. Yeah. But I want to take it too long. Let me do one or two more problems, and I am going to give the remaining as your homework, so you can try it out and come. Let's see this problem. Problem number 13. Look at problem number 13. Okay. Problem number 13. A and B, let A and B be two sets such that n of A is 3 and n of B is 2. Okay. There are 3 elements in set A and 2 elements in set B. Then we see that P2, Q3, R3 are in A cross B. Okay. So you can see that A cross B is going to have the elements in A as the first element and B as the second element. Okay. Since it is given A cross B, it's an ordered pair. Okay. So first element is A. Okay. So you can see that A, what are the possible values? P, Q,
P, Q, and R, sir.
So A is, from this we can see that A is PQR. Like that, you can see B is
2, 3, sir.
2, 3. Okay. Now find A and B. That's all. You're done. So that's all they're asking. Okay. From this we can see, observe that A will have P, Q, and R, and B has 2 and 3. Okay. It's getting late. I don't want to delay you much. Okay. So let's close here. I hope you followed, you understood some, the concepts here. We saw a lot of concepts in the beginning, and then we have been applying them. I hope you followed and understood the concepts, right, Harini?
Yes, sir.
Okay. So what I'm going to do, I'm having a few more problems. Okay. So I'm going to send this to you. I'll put it in the group. Okay. So please work on the other problems which are very similar. If you have any difficulty in solving any of these other problems, it's the same way only. Okay. So then we will discuss in the next class and then go to the next topic, which is relations. I hope உங்களுக்கு relations முடிச்சாச்சு இல்லையா? Sets, relations, and functions. In your school, they finished relations also, right?
Yes, sir.
Okay. So this you try. Okay. And if there is any doubt, I will clarify. Otherwise, we will move on to the next topic, which is relations, in the next class. Okay.
Okay,
I'm going
sir.
to close now. Okay. Good night, Harini. Bye.
Thank you, sir. Good night, sir.